In this video we'll derive the piston motion equations that you need. This is the Wikipedia page and you can see the website at the top here, piston motion equations. There's a diagram which shows the geometry, so we'll use that and we'll try and derive this equation here. X equals r cos A plus square root of L squared take away r squared sine squared A. A is the angle of the crankshaft from the top dead centre position. The way they've done it is they started with the cosine law, done some jiggery pokery, and they've ended up with it. But I'll show you what I think is an easier way, more intuitive. We'll start with the same diagram. So P is the centre of the piston. Let's just draw the piston on here so you can actually see it. That would be the piston. Yep. So that's the centre of the pin that goes through the middle of the piston. L is the connecting rod. R is the crankshaft. A is the angle from top dead centre of the rotation of the crankshaft. N is the bottom of the connecting rod where it joins onto the crankshaft. O is the centre of the crankshaft, and X is the distance that we're trying to calculate. So let's not start with the cosine rule. Let's get rid of that. We know this, so let's just get rid of that. Let's move these up a bit. It's all American spelling here. You notice that centre is spelt with a ER and not RE. So let's start by drawing a horizontal line there. Let's make it a bit thicker. So we'll do that. Now we've got two right angled triangles on here. Here's one right angled triangle there, and there's the other right angled triangle. The distance of this length is simply r cos A. R cos A. The distance of this length here, from here to here, is r sine A. R sine A. That should be a sine. Therefore, we've got, for this triangle here now, we've got the hypotenuse, which is L. We've got one length, which is r sine A, and we can use Pythagoras to work out this distance. So let me just do that in a different colour. This distance here is then, that distance there is the square root of the hypotenuse squared, take away that length squared, r squared sine A, and then we add on this r cos A. Now let me just do that on a different line. So to work out the total length x, x then is equal to this bit, copy that, paste it, plus that length. And that's the answer. Let's just check to see if it's the same as what they've got here. Yep. And then the maximum length of x, the maximum length of x is then when the piston is at top dead centre, so x max equals L plus R. The minimum value of x again then is equal to, when this is there, when that is around here, the minimum value of x will be L take away R. Therefore the swept length or the swept distance of the top of the piston, i.e. how far it goes right from the top to its minimum point, that distance there then is equal to 2R.